Hello. Today I'm going to go over the study of earthquakes. So these are just some of the basics of how we learn about earthquakes and some of the things that we've learned from earthquakes. In this first one here, we see a device, and this is a simple seismograph. And what this does is when there's an earthquake, well, what you're seeing in the picture here is this whole thing moves. So the ground here, which is brown, moves, and the device also moves. It might move up or it might move down. But the weight, which is on a spring, because of laws of physics, it doesn't move. It stays in the same place. But everything else around it moves. So it'll write on this paper and show the severity of the shaking or the motion up and down. So seismographs are devices used to detect the vibrations from earthquakes. Modern seismographs are more sensitive and accurate when compared to earlier versions. So modern seismographs just have a more complicated version of this, okay? When we read the rolls or the data from seismographs, we get these readouts, and it shows like the vibrations and the intensity of the vibrations. So over here at the beginning, there's no vibrations, but then you start to get a little bit of vibration, then bigger vibrations, and then really big vibrations. And what you're seeing in these seismograph readings is actually a lot of different seismic waves. Like first you have the P waves, and those are these smaller shaking events. Then you get an S wave where there's a little bit more shaking and vibration. And then finally you get the surface waves, which are very strong and intense. Those are the ones that cause the most damage. So reading a seismograph provides information about multiple types of seismic waves. Comparing two different seismographs can help identify an earthquake location. So these two seismographs are in different areas, and basically by comparing when the waves got to each one, you can identify where the earthquake came from. All right, some more information about what we've learned from earthquakes. This old white guy with the mustache is Richard Ullman. Richard Ullman was a geologist in the early 1900s. And we're talking about him because he learned something about the interior of the Earth based on earthquakes. So he was reviewing seismic data from seismographs around the world and noticed a pattern. And what he learned was something about the inside of the Earth here, because we can't go into the Earth to study it. Only the very top portion of the Earth is crust. Everything else is magma, right? We can't go into the Earth. But we do know some things about the Earth. And one of the first pieces of evidence that told us about the inside of the Earth and that the core is actually different from the rest of the interior was by looking at seismic waves. So we have S waves and P waves here. And Ullman found shadow zones on the opposite sides of the Earth from an earthquake. So for instance, with the S waves, earthquake happens here. The vibrations could go all the way through the Earth and be detected on the other side with seismographs. But there was this shadow where the vibrations weren't going through. Also with P waves, the vibrations can go all the way to the other side, but they were getting deflected and they were ending up in different areas than they should. So based on that data from the seismographs on the other side of the world, he and other scientists determined that the core was different than the liquid magma that made up most of the interior of the Earth. And we found out that there's a solid core or semi-solid core in some case. So the patterns suggest that the interior of the Earth was solid in some places. All right, let's go on. And now just a little bit about the intensity of earthquakes. So we have this picture here from one of the more famous earthquakes in modern human history, the 1906 San Francisco earthquake. And earthquakes have destroyed communities and altered landscapes throughout human history, and obviously before humans as well. But they've always had a big effect on where people lived and how people lived. The 1906 San Francisco earthquake, which we see here, destroyed many structures and started fires that burned down the rest of the city. So it wasn't just the shaking that destroyed the city. That did bring buildings down, but then it started fires that completely destroyed the rest of the city. All right, scale, looking at magnitude scale. So we've often heard of the Richter scale. Richter scale measures the magnitude of an earthquake. And the scale represents actual ground motion. So the higher the number, the stronger the earthquake. If it's 8 on the Richter scale, there's a lot of ground motion and a lot of damage. If it's a 4 on the Richter scale, there's not a lot of ground motion and usually very little damage. Okay, I hope this helps. Thank you very much.